These are the notes for LT5 in the thermodynamics unit. The goal is to describe how water's unique thermal properties, you could also say kind of the chemical properties, enable life to survive on Earth. All right, so we all know that water is important, but why is that? Okay, so there's a lot more to it than just drink your 8 glasses a day or whatever the recommendation is. Okay, if you're in class, you know that we open with these questions. And a couple things to keep in mind as we go through here. Okay, why does ice float? Which, in general, why do things float? Are they more dense? Are they less dense? And as water freezes, does its volume go up or does it go down? All right, because that directly relates to that idea of density, which we talked about in previous learning targets. So, we know most things, as they cool down, they contract. All right, and water does that to some extent until it hits a very, very specific range. And we say that water behaves either backwards or opposite, however is easier for you to think about it. I'm going to say backwards in a very specific and narrow range, in the 0 degrees Celsius to 4 degrees Celsius range. All right, so we know water freezes at 32 degrees Fahrenheit. 4 degrees Celsius is right around 39 degrees Fahrenheit. So ice, extremely cold. Okay, this isn't like bath water or anything like that. So if we know that 0 degrees Celsius is both the freezing and melting point of water, it depends which way you're going, okay, whether you're adding energy to melt it or taking energy out. But this is an important number. All right, so what will happen is if we're at 4 degrees Celsius and we remove energy, so the liquid water loses energy to the environment, so cold weather, let's say, and it goes to 0, which we know is where we're going to turn into a solid, water molecules will actually expand. They will lock in and it'll form like a lattice, like a crystal lattice. And so in other words, the volume goes up. And if we think back to density, okay, we've talked about that in previous targets. Just want to make sure we know which one. Okay, so LT4 here, remember we said if volume goes up, our density goes down because we're dividing by a larger number. Okay, so this means density decreases and things that are less dense will float. Okay, so that is why ice floats, because as it freezes, it actually becomes less dense. It takes up more space, makes it less dense, it floats. So now we've got solid water, so we've got some ice. As we warm it up until it hits this 4 degrees Celsius range, it's going to behave backwards. So remember, usually when things warm up, they spread apart. Not in this range. It's actually going to contract. So when we contract, that means the volume decreases. So if you all of a sudden are dividing by a smaller number, you get a bigger answer. So that would mean the density increases, and therefore the liquid portion of the water sinks. So if you've got a sheet of ice on a lake, as it starts to melt, the melted part, the liquid part, is going to sink. It's going to go below the ice. It's not going to float on top of the ice. All right, so first this may just seem like, okay, whatever, it's cool, it's unique. But thinking about in terms of life, so biological significance. Why does it matter for the survival of life here on Earth or really anywhere else? Let's think about this. Now, this is technically a sheet of ice, and I know ice usually doesn't freeze with ripples. It can, but usually doesn't. But here's our layer of ice. And then down here, this is going to be the floor. So here we go. We've got an extremely angry looking fish, and maybe we've got some algae down here. You know how good my drawings are not. But that's the bottom. All right. So thinking about this, if it's wintertime, what we see is that as you increase depth, so as you go farther below, we actually see a slightly increase in water temperature. So in the winter, most of the marine life is going to hang out towards the bottom. Okay, in the summer, this is kind of counterintuitive, because in the summer we know it's usually warmer closer to the surface. But if we think about why that is, it's because it's exposed to direct sunlight. In the winter, not so much. Okay, this is a big giant ice cube. All right, so if you can get away from that ice, it's going to be slightly warmer towards the bottom here. So using our directly versus inversely proportional language here, it is directly related. In the winter, deeper you go, the warmer the temperature. This is like an isolated layer. So maybe it's, about 1 degree Celsius just above the freezing melting point here. Down here, maybe it's 4 degrees Celsius, which, again, it's not like you're going to want to take a bath in this water, but it's enough that their metabolism can keep going and life can be sustained through the winter months. Now in the summer, it's more what we're used to. Okay, so in the summer, usually if you increase your depth, you see a decrease in temperature. Because now, the sun's hitting the open water all day, your warmer stuff, your warmer water is towards the top, and it's going to stay up there. Remember, it's not in this 0 to 4 range anymore. And so it's going to be less dense and the warmer water kind of sits up top. So this would be an inverse relationship where they respond opposite ways. Okay, so in the summer, it's more traditional, but in the winter, this is an insulating layer. It's going to stop this from freezing, but it's still going to be the coldest as you're closer to the surface. Now, make sure we understand this range, some things you might see. Let's say that I give you a problem where I say, what happens to water when it goes from 6 degrees Celsius to 10 degrees Celsius? If it's not in the 0 to 4 range, that's just something you have to know. 0 to 4, everything's backwards. This is outside of it, so water would behave like everything else. Okay, it would expand. It's going to add thermal energy, it's going to start to move around quicker, and it's going to expand. If we go 20 degrees Celsius to 10 degrees Celsius, we're cooling down. It's outside of that range, so it does what everything else would do. It would contract. But let's say now we're in the 3 degrees Celsius range, and we're going to go down to 1 degree Celsius. This is the backwards thing. So, things that are usually, when they get colder, they contract. Not here. Okay, we're getting close to turn into ice, so we're actually going to expand. If we went 1 degree Celsius to 3 degrees Celsius, things usually expand, but not now. This is like you had a sheet of ice and it's warming up in the spring here. And so it's actually going to contract and sink. All right, so take a moment here, I think, and just wrap your head around this 0 to 4. I know memorization's not the best, but we have to know that number. Okay, 0 to 4 degrees Celsius, water is special, and it's the reason that life can be sustained through the winter months. Good luck.